Hello, I'm Papia.
In this problem, we have the graph of a function f. And using that graph, we have to draw the graph of the first derivative, f prime, and the second derivative, f double prime. So the graph that's given to us is roughly drawn right here. So this is f. Now, we just have the graph. We don't have the expression for the function. So looking at the graph, we have to have an idea what its derivative and the second derivative will look like. So let's recall, how do we relate? What are the relationships between a function and its derivative? You know that derivative is basically slope of the curve. So if we have an idea of what the slope looks like, given this function f, we will have an idea of what the derivative curve will look like. All right, so notice right away, this is a parabola, okay? And it's opening down. So you know that if a parabola opens downward, then in the expression of the function, it will have a negative of x squared. Okay, so it'll have some kind of idea in that sense also what the derivatives will look like. Okay, let's go back and let's look at the slopes. You see that the parabola has this maximum point right here. And if you draw a tangent line to the curve right here, what is its slope? It's a straight line, horizontal line, and you know that horizontal line slope, which is the first derivative, is 0. So immediately you know that at that x value, f prime will be 0. So in the next graph below, I am sketching f prime. So at this point, so look at the x value here, it's about negative 0.5. So if you go further down, if this is your negative 0.5, f prime will be 0 here. Okay, so that is the first step. You figure out where the first derivative is 0. All right, now let's look at the left side of that point on the curve. What is the slope? You do the same thing. You pick a point and then you draw a tangent line. Okay, just roughly, just pick any point. So if you draw a tangent line, say here, on the graph of f, what do you think? What will the slope be? Don't know exactly, right? But look how the straight line is curved, right? You know that it'll have a positive slope. Okay, there's another way you can think about it. Do you remember? If the function is increasing, that means first derivative will be positive. It's actually if and only if, right? So look, the function is increasing to the left side of 0.5. So anywhere you draw a tangent line, it's going to give you a positive slope. What does that mean when we're graphing? So to the left side of negative 0.5, the function f prime, this new function, will be positive. So it'll be on the positive half of the y-axis. Okay, what happens on the right-hand side of negative 0.5? Well, look at the function. Function is decreasing. And if function decreases, that means what happens to first derivative? Yes, it is negative. So if you draw any tangent line on this side, look, it has a negative slope. And therefore, the first derivative, will be negative. And so when you draw the graph of the first derivative, it will be on the negative side of y-axis. So we know that. We know that to the left of negative 0.5 will be positive. To the right, it will be negative. Okay, what kind of curve will it be? Can we say for sure? Well, let's think about it. One more time. F is basically it's a parabola and it's opening downward. So I don't know the exact expression, right? But I know that it is something like a negative of a constant, say, some a x squared plus something else. right? And the something else, if you want to write even more generally, you can say it's a bx plus c. So this is a general parabola expression with negative in front of x squared term, so it opens downward. Okay, so think about it. If you take the derivative of this, what will it be? Well, x squared derivative is 2x with a negative a, so it will be negative 2ax. And bx derivative will be just b. C, the derivative is 0. So look at the first derivative. Do you see what kind of curve it is? It is just a straight line. So exactly, if your function is a parabola, first derivative is a straight line. So we don't know exactly what the slope is, but we know it's a straight line and it will pass through negative 0.5. So let's draw it. Okay, one more time. Look, on the left side, the first derivative is positive. So it will be on the positive side of the curve. And to the right side, the first derivative is negative. So it will be on the negative side of y-axis. So we don't know the exact slope, but we know that roughly this is what the first derivative of the function f will look like. So this is my f prime. Okay, we move on. We have to now draw the second derivative of f. But guess what? Second derivative of the function f is the first derivative of f prime. So you don't even have to look at f anymore. Let's concentrate on f prime, and using that we graph the second derivative of the original function, because f double prime is take this new function f prime and then take its derivative. All right, so we do the same thing again. This is a straight line. You can pick any point and see what the tangent line will look like. Well, if you draw a tangent on this line, say at that point, what does that line look like? Exactly the original function, the same line. Any point you choose, anywhere on this line, you draw tangent, it's exactly that line. So, what is the slope of tangent line? Do we know the exact slope? No, but we know it's going to be negative, right? It's a negative slope. Okay. Every point you choose, the slope is going to be the same negative number. So say the slope is, say the slope of this line is m. And we know that this is a negative number, right? Okay. So what will be the derivative of this line? At every x value, it will be that m. So what will the second derivative look like? Say m is right here. Think one more time. At every x value, you are looking at the slope of f prime. That will give you the values for our new function here. Okay, so at every x value, what is the slope of the tangent line? It is m. So at every x value, the value of f double prime is m. Therefore, what will f double prime look like? It is a horizontal line passing through m. So this is f double prime. And as you can see that we can continue this process, right? Using the same method, you can continue and find f triple prime and so on. But at least you have the idea how to look at a function f and draw the graph of its derivative. Thank you.